So we're going to move on with question number 5 and keep progressing like that. So we are asked to evaluate the following. So you see we're beginning to enter the territories of integrals, all right? Because the opposite of differentiation, which we've been doing all this while, is integration. So I'm going to see how we're going to simplify these questions. This first one you can see here, this is an indefinite integral. You see we don't have any limits, upper limits or lower limit, just like we have in the second case. You see we have 2 here and we have -1. These are called definite integrals, while the former is called an indefinite integral. So we're going to see how to walk through this type of questions. And you see the B parts, we ask to differentiate and all that. So let's just see how we can begin. Let's start from the first one. So this is the first question. Now, this is an indefinite integral. Now, let me just in case you don't know how to integrate, we've been differentiating. Let's say we have x squared, right? If I ask you to differentiate x squared, we're going to use the power rule. So this becomes 2x, 2 minus 1 in the power there becomes 1. So the answer will just be 2x. Now what happens if you want to go from 2x back to x squared? All right, because there should be a process. Since we have gone from x squared to 2x, we should have a counter process that takes us back to x squared. So this first process is what we call differentiation, which I believe by now you must have familiarized yourself with. And then that counter process that takes us from 2x back is what we call integration, this symbol. So the rule we use for integration is just the opposite of differentiation. Alright, so I'm just going to put them side by side. So remember, in differentiation, if you have, let's say, a raised to power n, is going to be, drop the power down, a raised to power n minus 1. Whereas in integration, if you have, say, a raised to power n, is going to be a raised to power n plus 1. Notice we now add 1 and then divide by n plus 1. So let's do that for 2x. Remember, this is 2x raised to power 1. So this is going to be 2x raised to power 1 plus 1. And we're going to divide by 1 plus 1, which will become 2x squared divided by 2. Now, 2 is going to cancel 2. Alright, so we're just going to have x squared as our answer. But then every time you integrate, you need to add the constant of integration that could be lost, when you do your differentiation. Now in this case, it's not looking very obvious because we have our x squared back, but if you begin to do other cases, you're going to see that it's going to prove to be very important. Now I'm not building anything on this, right? Remember, this is just like a crash course, but I just needed to keep this foundation so that we can run with it. All right, so now we have that away. So let's just begin to solve this particular question. Now notice that in this question we have 4x squared minus 3 raised to the power 9. Now we cannot begin to expand this, because if you want to expand a binomial that is raised to the power 9, that would be very, very terrible. So we're going to use the u substitution. Now look at what you're going to do. You're going to say that let u be equal to 4x squared minus 3. Now you're going to differentiate u with respect to s, so that's going to be du on dx. Okay, so when we differentiate this, notice we're going to have 2 times 4 will be 8, and then that'll just be 8x. Now since we have a dx term here from the original question, that means we want to make ds the subject of the formula, so we can plug the value back, right? So if we cross multiply, we're now going to have du is equal to 8x multiplied by dx. Divide both sides by 8x. You're now going to have dx on its own. You're going to have du on 8x. So this will be our value for what? For dx. And we're going to plug it back to the original question. However, if we rewrite this question, it's going to be the integral. Now, instead of 4x squared minus 3, remember, we said let it be u. So I can just replace 4x squared minus 3 with u. So this is going to be u raised to power 9, multiplied by x dx. But remember, dx is now du over 8x, right? Now notice that when we have done this, we can easily cancel the x terms, right? That's why it's very important to do that. So this over 8, I can now bring it out of the integral sign. So it's going to be 1 over 8, the integral of u raised to power 9 with respect to u. And we can clearly do this since we have u as the function, and then we have the u, right? So we're differentiating u with respect to u, and it makes sense, right? So this is going to be 1 over 8. Applying the this multiply by applying the rule that I just I've shown you just now is going to be u. 9 plus 1 is 10, so that would be u raised to power 10 divided by 10. Okay, then plus c. Always remember to add the constant of integration. On the denominator, we have 8 times 10, and 8 times 10 is simply 80, right? We're going to have u raised to power 10 divided by 80, plus c. Then remember, what is the value of u? We just need to put it back, and then we're going to be done. Remember, u is 4s squared minus 3. So our final answer for this question will be 4s squared minus 3, which is our value for u raised to power 10 over 80 plus c. So this is the final answer to the first question. Now let's move on to the next part. Alright, so this is the next question. Now you can clearly see that this is a definite integral because we have the lower limits and we have the upper limit. So we're taking the integral from -1 to 2. Alright, so the process is similar. We just need to differentiate the function, which is 2x plus 9. Thankfully, this is very easy to to integrate. So we're going to integrate first. Okay, so when we integrate this, what are we going to get? This is going to be 2x. Now remember, there's an x raised to power 1 here, right? So this is going to be 2x. That 1 plus 1 becomes 2, and then we divide by 2 plus. Now when you integrate a constant, remember the opposite, right? When we're differentiating, if you differentiate a constant, it becomes 0. But if you integrate a constant, it becomes you just add that independent variable, right? So if we integrate now, we just need to add x. So this is just it simply. All right, now we're not going to add plus c because this is a definite integral. So we're going to take the limit from -1 to 2. Now if I simplify this further, notice that on this side we can say these two cancel these two, right? So we're just going to have x squared. We're just going to have x squared plus 9x, and we're taking so this is just what we mean by taking the upper limit minus the lower limit. So simplifying this guy, now you're going to have 2 squared is going to give us 4 plus 9 times 2 is just 18. Okay, and then minus 1 squared is 1, and then this will be plus 9 times 1 here will give me -9. Then that -9 and this plus is going to be minus, so this will be 1 minus 9. 14 plus 8 is 22. So we're just going to have 22 minus 1 minus 9 is -8. So this will be minus again. So we're just going to get 22 plus 8, and 22 plus 8 is simply 30. So the value for this question is 30. Now let's move on to the next one. Alright, now notice the progression. We've solved this first one, that's the 5ai, and then we solved 5aii. Now I want to give you a little task. I want you to simplify 5aii. Alright, it's just the same thing. It's going empty. This is a definite integral, so you do the same way we have done the 5aii. Alright, so you're going to get the answer. So you can drop the answer in the comment section. Let me confirm whether it's correct, and I'll also give you the correct one there. Alright, let's move on to the B part. Now we're asked to find the derivative of the following function with respect to s, and then this is the function. So let me just solve it below. So if you have this type of function and you are asked to differentiate, because we are asked to find the derivative of y with respect to s. Now this is 4s cubed plus 5 all raised to power 4 multiplied, so there is a multiplication there, which is product. So every time you're taking the product of two functions, you're going to use what we call the product rule. Okay, so you're going to use the product rule, and the product rule is simply when you have two terms, right, we can call this term u and we can call this term v. So this v. Okay, so product rule says that you take the derivative of the first term, keeping the other one constant, plus you take the derivative of the second term, keeping the first one constant. So when you just do this, the answer you get is the derivative of this particular function. Okay, so we have said that, so I'm just going to write it formally. Let u be equal to 4s cubed plus 5 raised to power 4, and then our v is going to be the other term there, which is 3s squared minus 1 raised to power 3, and then our task is just to find the derivative of u with respect to x and the derivative of v with respect to x. Now, to simplify this, because we can't expand this bracket in this raised to power 4, you can't do that actually, but it's going to be strenuous and I wouldn't advise. So you can also use your chain rule here. Okay, I've already made mention of the chain rule in question number 2. So if you've not watched the question number 2, you can go back and watch it, where I explained everything, not everything really, but the basic idea behind chain rule. So go and see how it's been applied, and that's what we're going to do. But instead of showing all the workings, I'm just going to show you how to use the chain rule. So if you want to use the chain rule easily, just differentiate this normally, right? You see the power here is 4, so this is going to be 4 multiplied by everything, plus 5. But then this will not be the answer. You're not going to multiply by the derivative of the term inside the bracket, okay, which is 4s cubed plus 5. Now if I differentiate 4s cubed plus 5, differentiating 4s cubed, 3 times 4 is 12, and then I'll have x raised to power 2, 3 minus 1, and if I differentiate 5 is a constant, I'm going to get 0. So this will be our u prime. Let me just write it well. 4 times 12 is 48s cubed. Now I forgot to put raised to power 3 here, right? Because this is 4. If you bring the power down, remember you do the power minus 1. So the power minus 1 is going to give you this 3. Please don't forget to do that, right? So it's going to be 48s. Now I'm making silly mistakes again. So this is supposed to be 2, right? Because this is 2, okay? I'm doing this 4 multiplied by this 12s squared. That's what I'm doing. I just want to put them on one side. So that would be 4 times 12 is 48, and then your s squared. Then you have your 4s cubed plus 5 raised to power 3. And then on the other side, we do the same thing. Power will drop down, 3 multiplied by 3s squared minus 1, then the power reduced by 1, which becomes 2, but we'll have to multiply by the derivative of the term inside the bracket, which is 2 times 3 is 6, okay? So that would be 6s, and if you differentiate 1, you're just going to get 0. Now again, we just simplify things out. 3 times 6 is 18x, then multiply by this nonsense looking term we have in the bracket. Okay, now we have our u prime, v prime. So I'm just going to apply this chain rule. Please look at what I'm going to follow now. So just copy down, we have u prime first. So look at our u prime. That's 48s squared into 4s cubed plus 5, raised to power 3. And we need to multiply with v. Look at v, okay? This is our v. So our v is open bracket 3x squared minus 1 raised to power 3, and then we have plus, we have v prime. Now look at our v prime, right? Our v prime is 18x into 3s squared minus 1 all squared, and we're going to multiply that by our u, and remember this is our u, 4s cubed, okay? So I have 4s cubed plus 5 raised to power 4. Now this is actually the answer, but you can simplify further. At your level you're expected to simplify further. Notice we have 3s squared minus 1 on both sides, so it's a common term, okay? And what's the lowest power there? Raised to power 2. So this one is what we're going to pick. We're going to pick the one with the lowest power, okay? And then notice we also have 4s cubed plus 5 on both sides, okay? It's on both sides, so it's another common term. What's the lowest power? Raised to power 3. So this is the one we're going to select. Now write them together. This is just factorization, right? I also spoke about this in the previous questions we simplified. So I'm going to have 4s cubed plus 5 raised to power 3, and another like term I have is 3s squared. Right? Let me not call them like term, let me call them common term, minus 1 raised to power. Now that should be raised to power 2, the lowest. And then I'm going to open a bracket. Now notice that if I use this and divide, all of this will cancel, leaving only 48s squared. So I'm going to have 48s squared only there, plus. And if I cancel out, I hope I'm not making any mistake, please. I'm trying to do this as fast as possible, but you have to be very careful, right? Notice that, let me do this better, please. Let me do this better. So notice that this will cancel this completely, right? But this can't cancel completely because this is raised to power 2. This is raised to power 2. It's going to cancel and then leave only raised to power 1. Okay, so we're now going to have 3s squared minus 1 left. Good. And then plus. On the other hand, notice that this time around, this cancels this completely because that's raised to power 2. Why this cancels this, leaving another one there. Okay, so very good, we take notes. However, 18x is unchanged, so I have 18x and then into 4s cubed, plus 5. I'm going to write this our common terms again, which is 4s cubed, plus 5 raised to power 3 multiplied by 3s squared minus 1 raised to power 2, and then all multiplied by 48s squared into 3s squared minus 1 plus 18x into 4s cubed plus 5. Okay, this is now the final answer. Of course, you can, go on to simplify, but just if you want to save yourself the stress, I think this is good enough to be our final answer. So let's see the next question. You see, this is question 5b, and we just simplified this. Now look at the C part. We have said that given that y is equal to that function there, so we're asked to find 4 times the third derivative minus the second derivative of y minus 2y. Now I've done something like this. I've done something similar to this in the previous questions as well. Okay, so I think in question number 2a, where you just find the third derivative, find the second derivative. I think I'll just highlight that for you. You find the third derivative, okay, and then you find the second derivative, and then you already have y because y is given. This is the whole value here is y. All right, and then you're going to just multiply, do everything that you're asked to do. So when you must have simplified, okay, you are not going to get the final answer. So I'm not going to do this, right, because I've done that already in the question number 2. So I'm just leaving all these minor tasks, so you have an opportunity to practice everything that you've been learning thus far, if at all you've been following from the onset. So I'm also going to allow you with question 5c, okay, so you can test and build your muscles on the concept. So we're going to move on. So that's it for question number 5. So let's move on to question number 6. Alright, so this is question number 6. We are asked to differentiate the following functions with respect to x. Now see the first function there. We have y is equal to s cubed minus 2s multiplied by s squared minus 1 or raised to power 3. I hope you can already identify what is happening here. This is again the product rule. So again, I'm going to allow you to flex your muscles with this. So you're going to try to simplify this yourself again. Okay, now let's move on to II. So I don't think we've done anyone on II. So this is quotient rule. So we have y is equal to 2x plus 1 divided by s squared minus 1. So anytime you have division, you're going to use the quotient rule. And what's the quotient rule? Quotient rule states now remember again, we're going to call maybe the numerator u, I'm going to call the denominator v. So u prime multiplied by v minus v prime multiplied by u, divided by v squared. Now notice the similarity between the quotient rule and the product rule. Instead of plus, we are now having minus, and then we are also going to divide by v squared. So that's the only difference. So what's our u now? We say that our u is going to be 2x plus 1, and our v is going to be s squared minus 1. Now we need to find the u prime. differentiating u with respect to s, if you differentiate 2x, you're just going to get 2. Differentiate 1, you're going to get 0. And then v prime, if you differentiate s squared, you're going to have 2x. Differentiate 1, you're going to get 0. So just applying the rule now, we're going to have our u prime is 2, so this is going to be 2 multiplied by v, which is s squared minus 1, minus we're going to have, what's our v prime? Our v prime is 2x multiplied by u, and our u is 2x plus 1. Okay, and then we're going to divide everything by v squared. What's v? V is s squared minus 1, and then we're going to raise it to the power 2. So let me just expand this bracket. Let me see what we're going to get there. We're going to get 2s squared minus 2 minus, expanding this one, 2x times 2x will give me 4s squared, and 2x times 1 is going to give me plus 2x, and that will be divided by s squared minus 1 all squared. Now, using this negative sign, using the negative sign to multiply out the bracket, you can clearly see the negative sign there. We're going to get this is going to be 2s squared minus 2 minus 4s squared, and then minus 2x. Okay, and then this is all divided by s squared minus 1 raised to power 2. Good. Now you can clearly see like terms, so we can cancel out. See, this 2s squared minus 4s squared is going to give us minus 2s squared, right? So we have minus 2s squared minus 2x, and then minus 2. Okay, all divided by s squared minus 1 squared. Now notice that minus 2 is a common term, right? So we have minus 2, we have minus 2, we have minus 2, so we can actually factor that out. So we're going to have minus 2 into s squared. Now minus 2 dividing minus 2s will now be plus x. Okay, minus 2 dividing minus 2 will now be plus 1. Please, you just need to take note of all these little details. So we're now going to have divided by s squared minus 1 squared. All right, so I think this is good enough simplification. We can leave this as our answer. All right, so that's just it for this particular question. So let's move on to the next. All right, so remember, you're going to simplify 6i for yourself, just to test your muscles around it. You've done that before. Now this is quotient rule, which I have just simplified right now. Now this is about the last question, the b part. We are told now, I think we should solve it below since it's the last one. All right, so we are asked, this is the question. We are asked that if x is equal to 2 plus t squared and y is equal to 1 over 2 plus t squared, find dy on dx. Clearly see that there is a relationship between x and y. It is blazing clear. Notice that x is this, and then you're seeing the same thing here, right? Meaning that we can actually rewrite this. We can now rewrite, we can say that this implies y is the same thing as 1 over x, right? Because 2 plus t squared is equal to x. So let me just use the negative index law in indices to write this as x raised to power minus 1. So now I'm asked to find dy on dx. So let's differentiate y with respect to s. We're going to have dy dx to be equal to the minus 1, which is the power, drops down, and then x raised to power minus 1. Remember, you subtract 1 from the power. This is the power rule. So I'm just going to get minus 1 times s is just minus x. Then minus 1 is minus 2. Okay, so this is dy on dx. Very simple. Now let's try to put things out neatly using the negative index rule again. This can be written as minus 1 over x raised to power 2, right? So if I take this x raised to power minus 2 down, it becomes x raised to power 2 again. That's the negative index law in indices. Okay, so this will be our answer. We just have that dy on dx is equal to minus 1 over s squared. However, remember that x is what?